Yet again, it's been a while since the last devlog. Most of what I've been working on is under the hood stuff, things which need to be done or updated, but which isn't immediately apparent when you run the program. These things include XML files for easy template generation, rework of the map filter functionality, some multi-threading in the map filters, ecosystem simulation, and elevation initialization. XML files enables the creation of templates which can easily be edited outside of the codebase. All templates I've previously been using have been defined in the code. This is ugly and may make things hard to find or expand upon. The new system I've implemented makes it easy to add XML files to define templates. At the moment, I use these templates to generate flora and fauna instances, but in the future it will be extremely important when gameplay resources and stuff like buildings and technologies will be implemented. Here is an example of the flora XML templates. It's easy to add new plants. For instance, we can copy all this, paste it in and change some stuff. Maybe we call this plant lichen and make it grow very well in low temperatures, with a low need for sunlight. We run the simulation and voila, we have some lichen. At the moment, these templates aren't accessible in the build, but I might make them available later on for modding purposes. The map filters are what I use to change the map color. A map filter can be thought of as a mapping between tile data and mesh color. Different map filters will do this mapping differently. For example, this filter will map tile elevation, while this maps temperature. In the old system, the user selected a filter in the user interface. The user interface would send a signal to the graphics module. Then, based on a switch case, the corresponding mapping function was called. This was very ugly since every filter had its own function. With around 20 filters, that's 20 functions. I guess I started with this system because it's simple to implement, but it doesn't scale that well, and the code gets a bit messy with that many functions, doing pretty much the same thing. What I've implemented instead is to do the mapping using C# dictionaries and writing a general getColors function which takes a parameter instance as input. These parameter instances are stored in a dictionary and are written in such a way that they represent individual filters. The class mapFilter parameters contain what color map to use, what property to get from the tile data, and values for scaling. Here's the dictionary with filter entries. It's very easy to add new filters. If, for example, I want to add a filter for groundwater, I would do it like this. I assume that the tiles contain a property named groundwater. This value can be between 0 and, say, 500, and should use the rainbow color map. This is way easier than having to add a whole new function. So in comparison, the new way scales way better in terms of code readability, and it's easy to add new filters. When I reworked the map filters, I realized that this could easily be done using multiple threads, since the color of each triangle in the mesh is only affected by that specific tile. The optimal approach is probably to do this using shaders on the GPU, but I'm not a shader magician, so I'm still sticking to the CPU approach. There are also other things like parts of the ecosystem simulation and some initialization at the start of the simulation which could be done in parallel, so I've made them multi-threaded as well. And so far, I've seen some great performance improvements. I found that using Unity's job system is very easy. You simply define a job struct, inheriting from iJobParallel4, containing the execute method. The execute input can be used to run the simulation for a specific tile. In this case, the simulate method simulates the ecosystem for one specific tile I. You then simply schedule the jobs and wait until they finish. Also, I should probably mention that I'm doing some major overhaul on the erosion model, so in the meantime the simulation uses an old algorithm that is stable but gives very poor results. Keep this in mind, the most up-to-date erosion described in previous devlogs should be up and running soon. Before the next devlog, I hope to get back on track and continue with implementing some gameplay mechanics, in particular the resource system. And that's all I have for this week. As usual, the program can be found in its entire state on itch.io. Thanks for watching.